Okay, so first of all, what are we doing? Second of all, why does it work? Okay, so let's take a quick look here at what we're doing. First of all, this was example number 2. We're going to come back to these in a second. So example number 2. All right, so let's go back to example number 1 again. And example number 1, if you recall, was the GCD of 120 and 45. Okay, now, what we really did was we actually divided, if you saw here, actually, let's put this over here, and let's go back, and we will copy this so that we can have it onto this page, and let's paste it. Okay, great. So we start off with this. Ignoring this step, just starting right down here with this guy, this mechanism we just did. We subtracted off 45, but we didn't just subtract off 45 once. We actually subtracted 45 off twice. And when we subtracted 45 off twice, what we were left with was 30. Now, we can summarize that actually in a little division problem. We can summarize the fact that we subtracted 45 twice. In other words, 45 goes into 120 2 times. So 120 is equal to 45 times 2, but there's a remainder. What's the remainder? The remainder is 30. Okay? So we divided that. Now what we do after that, we get down to 45 and 30, and we subtracted 30 from 45 once. So really what we did was we divided 45, we divided it by 30, and we saw that 30 goes in 1 time, and the remainder is 15. Okay? Well, then what did we do? Well, then we divided 30 by 15, and we saw that 30 is equal to 15 times 2. Now, look, there's no remainder, so we can say that the remainder is 0, or we can just leave it off completely. Here we have 2 numbers that are multiples of each other. The smaller one then is the greatest common divisor of the 2 of them, clearly. Now the question is, how do we know then that 15 is also a divisor of 120 and not only the greatest common divisor? But you can see how what we did over here, what this little mechanism of subtraction really amounts to repeated division. Okay, so we can do our second example. Let's go back here, take this, copy it, and we will paste it there. Great. And then we will take we'll start over. Okay, so we started with GCD of 1989 and 867. Okay, great. So the first thing we did was we subtracted 867 from 1989, but we did it, let's see here, there's 1, and then we did it again, there's 2, and that was it. So we did it 2 times. So from that, we know that this can be sort of summarized in a division problem. 1989 is equal to 867 times 2, and then the remainder we see turned out to be 255. Okay? From there, now we took 867 and we divided it by 255. Now, how many times did it go in? Well, let's see here. We did once. We subtracted 255 once, twice. Oh, actually 3 times. 3 times before 255 became the bigger one. So that means that this is 3 times, and then the remainder there after the 3rd time happened to be 102. So if you take 255 times 3, what do you get? You get 765, and then if you add 102, you get 867, which is what you're supposed to get. Okay, great. Now we're going to take 255 and we're going to divide it by 102. Now 255 divided by 102, how many times did we subtract that? We subtracted it, let's see, here's 1 subtraction, here's 2 subtractions, so 2 times. So 255 is equal to 102 times 2, that's 204. We subtract and we get 51. So we got remainder 51. Okay, so now we do 102 is equal to 51 times 2, and we get a 0 remainder, which we can leave off. All right, and now we know we're done. So 52 goes into 102. That is the biggest divisor of these two. And for some reason, which is yet to be seen, 51 also turned out to be the divisor of 867 and 1989. Okay, so you see how the steps work, but now the question is, why does the process work? Okay, so let's check that out. Let's answer the question. Okay, so let's take two numbers. We have two numbers, A and B, and for this argument, we're going to say that A and B are both greater than 0, just because when we find greatest common divisors, we are usually working with positive numbers. You can extend this to negative numbers. I'm not worried about it for right now, so we're just going to leave it with positive numbers. Okay, so we want to find the GCD of A and B, right? Well, actually, we don't want to find the GCD. I'm sorry. We're going to learn something about the GCD. So we're going to call the GCD of A and B. Let's call it X. Okay. Okay. So now, really, there's actually two cases. In case 1, we have A is equal to B. Well, if A is equal to B, then the GCD, then X, which is equal to the GCD of A and B, is equal to the GCD of A and A, or B and B. That doesn't matter. And the GCD of, a number in itself is just itself. That's sort of trivial. All right. So if A equals B, then we know that X is equal to A, and it could have been B. So we'll just put that X is equal to A or B. Okay, now case 2, let's say that A is greater than B. Now we can say that without loss of generality, which means that we're not missing any cases here, because if B were actually the greater one, all we have to do is switch the order and then rename them, and then A would be greater than B. So it's fine to say that A is greater than B. So we're going to assume that A is greater than B. Okay, great. Now, okay, what are we going to do? Now, the fact that the GCD of A and B is equal to X, that's what we called it, that implies that X divides A and X divides B. Okay, and we can use that to come up with two equations. We can say that that A is equal to some multiple of X, and we'll call that, X times I. Okay, and we can say that B, conversely, is also a multiple of X, and maybe X times J. Okay, so let's look at that first equation there. X is equal, A is this one. All right, we're going to look at this one, and what we're going to do is we're going to subtract B from both sides. All right, so we have A minus B is equal to Xi minus B. But we know that B is equal to X times J, so let's just replace that. So replace it with X times J. I guess you could just say we subtracted those two equations. That might have been an easier way to phrase that, but I wanted to hammer home the point. Okay, so that means that A minus B is equal to X times I minus J. Well, from this means that clearly, I love it when mathematicians say clearly, because it's usually not clear, but in this case I think it actually is. Clearly, X divides A minus B. Okay, I think that was pretty obvious, but we're going to go from there. All right, so we know that X is a divisor of A minus B. Great. What we really want to know, though, is that when we subtract the two of them like that, we want to know that X is the greatest common divisor of A minus B, the difference, and B. So we need to do a little bit more than that. Now, we do know, however, that now we know X is a divisor of A minus B, and also from before, we know that X divides B. So we know that X is a divisor of A minus B and B. The question is it the greatest common divisor of A minus B and B? Okay, so let's look at another divisor. Let's take any divisor of both a minus b and b. Okay, and we'll call it d. Now, d times n, I'm just following my notes here, make sure I get the right letters. Yeah, let's say that d times n, the fact that d is a divisor of a minus b means that d times some number, which we're calling n, is equal to a minus b. Okay, great. And also, we know that d times some other number, m, is equal to b. Great. Oh, actually, now that reminds me of something real quick. Let's go back up here. Right here, I minus j is not 0. Now I know that I minus j is not 0 because I know that a and b are not equal. Since a and b are not equal, I and j cannot be equal. And since I and j aren't equal, then I minus j can't equal 0. So that's kind of an obvious thing, but it's an important thing. All right. Okay, so what does this tell us here? So I have my number d, which just remember is any divisor of a minus b and b. Great. So let's add these two things. So we have dn plus dm is equal to a minus b plus b. Now if we simplify that, we get d times n plus m is equal to a. Well, this implies that d divides a. Okay, so we showed that any divisor, and this is a little bit circular. Hopefully you're noticing that. You're saying, Mr. Fancy, this is a little bit circular. It is. We saw earlier that if a number goes into a and b, it goes into the difference a minus b. So you would think that if the number went into a minus b, the difference and b, then it would go into a also. And it does, in fact. Okay, but so, well, yeah, and just to make sure we have our notes thoroughly updated, we know that d divides b. Okay, so d is a common divisor of a and b.